Welcome to The Explainer. Today, we're building your absolute ultimate statistical toolbox for conquering Chapter 13. You know that feeling when you're staring at giant tables of data and wondering how to make sense of them without, totally pulling your hair out? Well, you're in exactly the right place. We are going to break down the exact methods you need for explaining the chapter and totally mastering group data.
So let's just dive right into the core problem here. Finding the mean is super easy when you just have a handful of numbers, right? You just add them up, divide by the total, and boom, you're done. But what happens when you have massive data sets that are all grouped into broad intervals? Think about like the grades of an entire school or the daily wages of literally thousands of factory workers. You don't have those individual numbers anymore. You just have ranges. So how do you find an accurate average then?
Here's our roadmap to level up your skills today. We'll be looking at ungrouped to grouped data, method 1, which is the direct mean, the assumed mean shortcut, the step deviation shortcut, finding mode and median, and finally, the empirical relationship. Let's get to it.
Section 1. Moving from ungrouped to grouped data. To kick things off, we're transitioning from the simple, ungrouped data you probably remember from Class 9 to the much more complex, grouped frequency distributions of Class X. We really have to upgrade our approach here.
Okay, so to actually make this grouped data workable, we first need to find a single representative number for each range. Think of it like choosing a spokesperson for each group. We call this spokesperson the class mark, or XI, and it's incredibly simple to find. You literally just take the lower limit of your range, add the upper limit, and divide by 2. It's the exact midpoint. This single number is going to stand in for every single data point hidden inside that interval.
Moving to Section 2, Method 1, the direct mean. Now that we have our class marks acting as our data spokespeople, let's pull out our very first tool. This is, hands down, the most straightforward way to calculate your average.
Take a look at this frequency table. See how highly visual and structured it is? We've got our class intervals on the left, and the number of students, which is our frequency, or Fi, right next to it. And we've calculated our class mark Xi for each row. Now we just simply multiply the number of students by that class mark to create our brand new Fi times Xi column. So for example, 2 students times a class mark of 17.5 gives us exactly 35. Once you've got that final column filled out, the formula is honestly a total breeze. You sum up that entire final column, that's your sigma Fi Xi, and you divide it by the total number of students, or sigma Fi. It is essentially the exact same logic as calculating a basic average, just, scaled up for groups. But here's where we hit a wall, and it really brilliantly illustrates our core conflict. The direct method? It works perfectly. But man, it is an absolute nightmare of calculation when the numerical values get too large. I mean, imagine if your frequencies were in the hundreds and your class marks were in the thousands. Multiplying those out by hand isn't just tedious, it's practically begging for silly arithmetic errors. We absolutely need a better way. Which brings us to Section 3, the assumed mean shortcut. Let's look at our first major shortcut. Think of this as a power drill for your mathematical toolbox.
So, instead of multiplying those massive numbers, what if we just made the numbers smaller before we multiplied them? We can actually do this by picking one of our class marks right in the middle of our data and just declaring it our assumed mean, which we call A. Then, we subtract this assumed mean from every single class mark to find what we call the deviation, or DI. By doing this, we dramatically shrink the numbers we have to work with. Just look at how beautifully the numbers in that DI column shrink. Here, we chose 47.5 as our assumed mean. When we subtract 47.5 from the other class marks, we get super manageable numbers like -30, -15, and hey, even a 0 right in the middle. Multiplying these new, way smaller deviations by our frequencies saves us an immense amount of calculation time, and honestly, a lot of mental energy.
Now, of course, we can't just permanently shrink the data and walk away, right? Because we subtracted our assumed mean A earlier to make the math easier, we simply have to add it back at the very end to balance the equation. You calculate the average of your smaller deviations and then just add A back in. Boom, you have your true mean, with literally half the headache.
Section 4, the step deviation shortcut. But hey, what if those numbers are still a little too bulky for your liking? Enter the boss level of Chapter 13.
So the assumed mean method shrinks numbers by subtracting, while the step deviation method takes it a step further. If your deviations share a common divisor, which, by the way, is almost always the class interval size, what we call h, we can divide them to shrink the math down even more.
We are literally turning 2 or 3-digit numbers into tiny single-digit integers.
It's a really simple 3-step algorithm. First, find your deviation, just like before. Second, divide that deviation by the class size h to create a brand new microscopic value we call ui. And third, multiply that tiny ui by your frequency.
Now, what's really wild here is how those intimidating large numbers have just completely vanished. Look at that UI column. Because our class size h was 15, we divided our deviations by 15, and we're left with incredibly simple calculations like -2 times 2 or -1 times 3. I mean, you can do this entire column in your head in about 5 seconds. And just like the previous shortcut, we do have to undo our little mathematical trickery at the end. Because we divided by h to shrink the numbers down, we multiply our final sum by h, and because we subtracted our assumed mean a at the start, we just add a back in. I know it looks complex on paper, but logically, you are just reversing the shortcuts you took to make the math easy.
Section 5. Finding Mode and Median. Let's switch gears for a second and look at the other two tools in our kit. Finding the mean is great for averages, but sometimes, the data tells a different story.
While the mean gives us an overall average, the mode identifies the most popular bracket, like say the most common shoe size or the most watched TV show. And the median pinpoints the exact middle of our dataset, splitting it perfectly 50-50, which does require calculating cumulative frequency. But hey, here is a massive warning sign. Before you apply the formulas for either mode or median, your class intervals absolutely must be continuous. If one class ends at 10 and the very next one starts at 11, you have to adjust them to 10.5 to close that gap. Definitely do not forget that step.
Section 6. The Empirical Relationship. We've built an incredible toolbox today for explaining the chapter. But there is one final, almost magical connection between these three concepts that will absolutely save you on an exam.
So the crucial takeaway here is this empirical relationship. 3 median equals mode plus 2 mean. This isn't just some random piece of trivia to memorize. It's actually a structural reality of how these measures of central tendency relate to one another in grouped data. And this leads us to our final provocative thought for the day. If a question asks you for the mean, median, and mode, and you've already done the really hard work to find 2 of them using those giant tables, why on earth would you calculate the third one from scratch? By utilizing this simple empirical equation, you can completely bypass complex tables for that third metric. You just plug in the 2 you have, do some basic algebra, and boom, you're done. Mastering this chapter isn't just about memorizing formulas. It's really about knowing which tool to use and exactly when to use it, so you're working smarter, not harder. Thanks so much for joining me, and I'll see you on the next explainer.